Kia ora Year 10. Here's video number 4 from Gamma Chapter 11. So these questions are slowly getting harder, and in this one we have to start thinking about algebraic common factors that are not just an A or a B or an X. And you'll see what I mean when you look at these 6 examples. So they suddenly look a whole lot worse, but they really aren't. The big idea is the idea of a factor. Right? And so going all the way back again to about year 2 or 3, we know that 2 3s are 6, right? And we know that that's the same as 3 lots of 2, that's 6 as well. And it's that idea that we're applying here. The difference in these questions is that my factors are not just going to be an x, right? So we're now used to doing things like this, x to the power of 4 y squared divided by, I don't know, x squared over y, right? So back in video 2, I think, or maybe even video 1, and back in year 9, we learned how to simplify things like this. And we'd end up with x squared y, right? So we're used to saying, well, this is something to the power of 4, and this is the same something to the power of 2. And we went through a phase where we wrote that all out, but we pretty quickly got to subtracting the powers and ending up with a 2 here. The same thing with the y's, right? We had y squared divided by y. The y here is y to the power of, where's my pen gone, invisible 1. And so when we subtract the powers, we get y. So let's take a look at these, because I think that often students do start to freak out when they see these, and you really don't need to. So I'm going to work through all 6, but I want you to write them out and leave some space between each one. And have a go and see if you can spot the common factors. Okay, so working through them down here. The first one is 1 to get us warmed up, and it's where the common factor is a simple 2. Right? We've got 2 lots of this thing here in brackets, and it's divided by 4. So we're focusing on the numbers. The common factor in here is 2. So 2 divided out of the top and bottom leaves me with 2 down here, and I end up with this. You can think of this as one lot of 3a minus b divided by 2, but we don't want to write it like that because we never bother to write 1 times anything. We could write it like this, 3a minus b divided by 2. But if you're in my class, you will have heard me say lots of times that this division sign works like an invisible bracket for what's on top of it. So we don't need those brackets there anymore. It's just 3a take away b divided by 2. And when we see that, we know that we're thinking of this as a blob all together before we go and divide it by 2. Okay, so just doing that one more time without all of the little steps, what would we do if we encountered this somehow in real life? Well, we'd look at it and we'd say my common factor is in the numbers, my common factor is 2. We'd write it like this, and then we'd just go straight to my final answer, which is 3a minus b divided by 2. Okay, so they're going to get a little bit harder from here, but not really that much. Once you've spotted the common factor idea, you should be away. So first we look at this and we say, well, this means 15 times this. And this means 5 times this. So we've got 15 divided by 5, which is 3. And x plus 4 divided by x plus 4, which is just 1. So we can simplify like this, right? This divided by this gives me 1, so my final answer there is 3. Next one. I've got x plus 3 times x minus 2 in the numerator divided by x minus 2. Now, apart from the fact that we've got some algebra, this really is the same as when we first learnt how to do things like this. 2 times, let's think of one that actually is very similar. So 3 times 7 divided by 7. 7 divided by 7 is 1, so we're left with 3. Now what we've got here in the question is very, very similar. The common factor is x minus 2. So they simplify to leave me with x plus 3. And again, I started out with brackets, right? But the reason that I had to start with brackets is because if I didn't put them in, I would have this. Right, so let's look at these two things. Look at my order of operations. In the first one, I've got x plus 3 times this. Now, by order of operations, I have to do this first. So this is the same as x plus 3x minus 6, right, which is 4x minus 6. But what we had was not that. It was this whole thing times this whole thing. Now, when we multiply those two things together, we get a quadratic. And some of you will have seen that in Year 9, but lots of you won't have seen that yet. Now, we're actually going to come back to that topic in about 6 weeks' time. So I'm not going to go through that now. But they're completely different things. So that was a very long way of telling you that when I'm writing an expression out like this one here in question 3, it really matters that I've got these brackets here and these brackets here, because it's saying take this blob and times it by this blob. But now that we've simplified, we're left with just x plus 3, and so we don't need the brackets anymore. Okay, number 4. Now I put this one in to remind you that the order of multiplication doesn't matter. Okay, so we could rewrite that like this: x plus 5 times x divided by x plus 5 times x minus 7. But we never bother doing that, but we could do that. It makes it really easy to see that my common factor is x plus 5, and that when I divide through by that, I'm left with my final answer, which is x over x minus 7. And again, once I get to the end, I can drop the brackets from the x minus 7. Number 5. Now these look bad, but they're really not bad. The key thing here is to think of a minus b as a blob. Right, so I've got a blob cubed divided by the same blob squared. So it's just like when I was first starting algebra and I had x cubed divided by x squared. What do? Well, we can simplify using our rule that if I've got the same thing, I just subtract the powers. Or, for the first one that we're doing, I can write it out the long way. A minus b times a minus b times a minus b divided by a minus b. But you can see that this is going to get pretty tedious quickly. Now, I'm not sure that that was the example I've done. I think I've changed my numbers. Let's do this one first anyway. So here, this simplifies, leaving me with a minus b. But I have a feeling, I'm looking at a piece of paper next to me while I do these, that's why this is not quite the same. Yeah, so the one that I put in here for you on purpose had a power where that was too long to write out. So it's a minus b to the power of 17 over a minus b squared. So all I have to do here is do this, a minus b to the power of 15, right? I just subtract the powers. And the same thing for this very last question that I'll do up here. I've got a blob cubed divided by a blob squared. Because this is a common factor, all I have to do is subtract the powers, right? So this one will be x plus 2, and if I'm going really slowly, I'm going to go 3 minus 2 is 1, and put the power of 1, but that's just the same as x plus 2. And again, I can drop the brackets. Now there's lots of little subtle things in this exercise that I really like, so it's worth spending some time on. And if you've got any questions about anything like why did she drop the brackets here and why not somewhere else, please just send me an email. For those of you watching who need it, the email is this. Okay, and I'll do my best to give you a hand. Thanks for watching. There are 3 more videos to come from this chapter of Gamma, but I'm not going to do them tonight, so it'll definitely be sometime tomorrow or the next day.